What does it take to own an industry so completely that everyone else depends on you? Most people would say, invent something, build the best product, patent it, defend it, win. But China, in whose hands the entire electric economy depends on, did none of that. In fact, the technologies that power the modern electric economy, be it the battery, the permanent magnet, the power transistor, almost all of them were invented in American or European labs. China did not invent any of it. And somewhere in that gap, between inventing something and owning something, the entire future of the global economy got decided. This is the story of how that happened. But before we get to China, we need to understand what's actually at stake. There's a set of technologies sitting underneath almost everything the modern world runs on. Electric vehicles, wind turbines, drones, heat pumps, you name it. All of them essentially draw from the same four building blocks. First is lithium-ion batteries. This is the storage layer. Since 1991, battery pack costs have fallen 98.7%. And that is the number one reason why the EV industry exists at all. Second is magnets and electric motors. This is the action layer. These magnets sit inside every motor worth talking about. And without them, nothing moves. Third is power electronics. This is the control layer, the inverters and chips that shape electricity exactly in the right form thousands of times per second. Essentially the nervous system of every electric product. And fourth is embedded compute. This is the intelligence layer. The microcontrollers that read sensors, runs calculations, and tell everything else precisely what to do. These four layers stacked together have a name now. It's called the electric stack. And China is maintaining clear leadership across the stack. 75% of global lithium-ion batteries, 90% of the neodymium magnets, 9 of the top 10 solar inverter manufacturers, and in embedded compute, it's closing very fast. But how did that exactly happen? To answer that, we first need to go back to a theory that became the operating logic of the Western economy in the 1980s and 90s. It was called the smiling curve. The idea was simple. In any manufacturing industry, value is not distributed evenly. It concentrates at two ends, R&D and design at one end, branding and services at the other. The middle, which is the actual production, is low-margin commodity work. So the rational move is to keep the ends and outsource the middle. For a generation, this felt like wisdom. American and European companies kept the patents and the prestige. They let Asian manufacturers take the factories. They told themselves that as long as they held the IP, they held the power. What they didn't account for was this. Manufacturing is not just assembly, it's knowledge. It's the engineers who figure out why the yield rates drop in humidity. It's the supplier relationships that lets you iterate a battery design 15 times in a year instead of 3. It's the understanding of materials, tolerances, failure modes built up across thousands of production decisions that never get written in a patent. When you outsource the factory, you don't just outsource the labor, you're outsourcing the learning. An economist, Clayton Christensen, gave this dynamic a name, the law of conservation of attractive profits. When one layer of the value chain gets commoditized, value migrates to the adjacent layer. America bet that intelligence, be it software, AI, or design, would always be the high-value layer. That physical manufacturing would always be the commodity. But guess what? That bet is looking worse by the year. And you can trace the turn to a single transaction. In 1982, a General Motors scientist named John Crote developed the neodymium iron boron magnet, the most powerful magnet ever created. GM spun this into a company called Magnequench. For a decade, Magnequench was a national asset. It supplied 85% of the neodymium magnets inside American precision-guided missiles. Then, in 1991, GM took a $8.5 billion loss. The company that had once tried to be everything, from technology to finance to aerospace, was forced down to go back to doing one thing that they do best, making and selling cars. Everything else had to go, and Magnequench was everything else. So in 1995, GM put it up for sale for $70 million, roughly what a mid-tier tech startup raises today in Series B. Not because it wasn't valuable, but because GM was bleeding, and the magnet company did not fit into the balance sheet that needed saving. Magnequench was then acquired by a consortium that included two Chinese state-linked entities. Pentagon officials objected, but the State Department cleared the sale anyway. The condition was to keep US operations running for 5 years. But the day the condition expired, the Indiana factory was shuttered, 450 workers were fired, and every machine was cratered and shipped to Tianjin. That is how China entered the rare earth manufacturing business. The same playbook ran with batteries. A123 Systems, an MIT spin-out with breakthrough lithium iron phosphate technology and a $249 million grant from the US government, went bankrupt in 2012. It then got acquired by a Chinese firm named Wangjiang for $257 million. The technology, the team, the know-how, all gone. These technologies were invented in the West. The factories moved east, and the knowledge moved along with the factories. To understand what a full-stack ownership produces, look at BYD. Wang Chanfu founded BYD in Shenzhen in 1995, the same year Magnequench was sold, with a $300,000 loan from his cousin. The company's first product was a rechargeable battery for Nokia phones. For a decade, BYD was just a battery company. It learned the chemistry at the factory floor, not in a lab, on a production line, making millions of cells watching what failed and why. In 2003, Wang bought a struggling car maker for $33 million, and every analyst on Wall Street called it a mistake. 5 years later, Warren Buffett invested $230 million into BYD. In fact, Charlie Munger was so impressed with the founder, he called him a combination of Thomas Edison and Jack Welch. And then, in 2020, BYD did something no one else could. It unveiled the Blade battery, a lithium iron phosphate pack redesigned from the ground up to be simultaneously safer, denser, and cheaper than anything else on the market. The breakthrough was only possible because BYD made both the battery and the car. The feedback loop between the two was entirely internal. No other company had that. In 2025, BYD sold 2.26 million electric vehicles, more than Tesla, more than any other single automaker on earth. Its entry-level car, the Seagull, costs only $9,000, not because it is subsidized to that price, but because 30 years of owning the entire stack, from raw material to finished vehicles, is actually what it costs to build an EV when you control every layer. And here's the compounding effect. Once you own the stack, you own the template. The same batteries, the same motors, the same chips, just assembled differently. Cars become drones, drones become robots. Each new product costs less to enter than the last. China isn't winning separate industries. It's winning one platform and applying it to everything else. Today, BYD makes all its critical components in-house and manufactures everything from cars to home energy products to much of the world's drones. All of it from a phone battery company that started with a $300,000 loan and 20 employees. That is what the smiling curve looks like when you own the middle. The West is now attempting to rebuild something it spent 30 years dismantling. The United States passed the Inflation Reduction Act, $400 billion to reindustrialize clean energy manufacturing. Europe is pursuing similar programs, and both are serious efforts, but both face the same fundamental constraint. You can build a new factory, but you cannot instantly rebuild the knowledge ecosystem that makes it competitive. The process engineers, the material scientists, the supplier network, the product intuition, that takes time that neither the IRA nor the policy instrument can compress. And China is not waiting. It has begun restricting exports of rare earth magnets, battery manufacturing equipment, and lithium processing technology. Each restriction is quiet, and each one tightens the dependency slightly further. The electric stack is now becoming what oil was in the 20th century. Geopolitical leverage baked into the infrastructure of daily life. With one crucial difference. Oil is extracted. You either find it or you don't. But the electric stack is built layer by layer, decade by decade, through a series of decisions that compounds only in one direction. What China understood, and what the West is still coming to terms with, is that owning an industry doesn't require inventing it. It requires the patience to manufacture it at scale for long enough that everyone else forgets how.